Hey there, this is Lester Martin, and I wanted to give a quick overview, a rundown of a speech, a presentation I'll be delivering at the DevNexus 2017 event tomorrow. So this is just a quick dry run for me. I thought I'd record it, and if it was any good, put it up on YouTube. So hopefully you're hearing it there, and if that was the case, then I think it's in pretty good shape. So the name of the topic is, as you see on the screen there, Transformation Processing Smackdown, Spark versus Hive versus Pig. So, Smackdown implies we're going to compare and contrast these three different technologies, these three big data, Hadoop or Hadoop-ish technologies out there. And I'm going to focus, as you'll see when we talk about the agenda and some of the requirements, really on a phrase I'm calling transformation processing. So again, a little connection before content. I mentioned my name is Lester Martin. I work for a large, major Hadoop distribution vendor. Maybe the colors and some of the casual words I say throughout this presentation will tell you who that is, or you can drill down and go to lester.website. Definitely you'll find out pretty quick about me. There's an email address. At the end of the presentation, I'll put this information up there as well. So for a rough agenda, I'm going to focus primarily on taking a few minutes and present these three frameworks. Won't be enough if you're totally new to these technologies, and it will be too much if you're very comfortable with them already. But you want to take a few moments and run through each one of those three and talk about them. And then the rest of the agenda will really be focused on some of the requirements from the ETL, ELT space, again, focusing primarily on that transformation processing arena. And I'll talk a little bit more about those requirements in a minute. I put a little cautionary tale that's not a data science or machine learning topic. That's mainly because at the conference I'm in that track. I did want to make sure folks knew what they were getting into. And I will present lots of code. It may be simple code that fits on the screen, but this presentation is pretty chock full. As a gentleman that's been programming most of my life, I would say we all have our standard disclaimers. You see several of those on the screen there. I guess that first one mentions a GitHub project where all the code that you see on screen here, at least working versions of that. Sometimes I had to clean them up for the slides, but I believe they're all working for the most part. But definitely, if you want to see them in action and you want to try them on your own, pull down that, clone that GitHub project that you see listed there. Always a bunch of ways to solve a problem. Hint, wink, wink, and especially in Spark. That's Spark SQL especially. That's command line tools, not GUI tools. I'll be focused on here. And a warning. While there are lots of code examples, all code always works just fine in the IDE called PowerPoint. So have a little fun with that. So of those three frameworks, I'm going to actually pitch them primarily in Pig, Hive, Spark when I present the code examples and whatnot. I think it just kind of flows after seeing this from top to bottom. I think it makes a little bit more sense sometimes. But Pig, it's been out there a while. It's a data flow, a scripting language. It's very focused, at least in practice, very focused in the Hadoop arena. You can do more things with it, like almost all good Java frameworks. But that's the space that you see it's heavily being leveraged. Lazy executing style model, pretty commonplace in some of these big data tools. Wait till some I/O operation is called, and then backtrack and figure out how to do that. Usually, you write a script, run it through a command line or a GUI tool, or there is an interactive shell, as we kind of imply right there. Pig, what's nice about Pig is a simple a novel framework in some ways. It just has a limited number of features, functions. It's not a dedicated top to bottom, full multi-purpose programming language. It's really focused on, again, data flow, data pipeline, etc. So there's some of the commands you'll see, and you'll see them later. Again, we won't have time to slow them top to bottom down. Of course, I advocate, and the place I work at, maybe, I advocate maybe using the Mbari Pig view that exists out there. There are other web-based tools that you can try as well, but this is a pretty darn good one. Lots of good color coding. End of the day, you're still writing code, but we do frame it up pretty nice in a nice browser. The second technology we're going to talk about today, or use for examples, is Apache Hive. And Hive is really just that data warehouse system for all things Hadoop. So this is your way to mask or map some type of logical schema, table definition, etc., to data that exists out there in the file system for Hadoop, the HDFS, Hadoop Distributed File System, and run queries against that. That's the primary purpose. Those two came out, Hive and Pig came out of the fact that Java MapReduce was the existing original framework that was out there. A lot of folks weren't necessarily Java programmers. They wanted something a little bit more easy to get their head around, or maybe more aligned, as in the case with Hive, with the tools they already understood. SQL is pretty much the business language of choice out there. So these technologies originally just simply rewrote themselves, ran at runtime as Java MapReduce. They have grown up and have other execution engines they can run as well. So again, Hive, again, not going to walk through that, but the things you think about in SQL, data types, functions, windowing, those kind of ranking, all that kind of good stuff, you should expect to see that in Hive as well. And then just a quick picture to kind of visualize that the reality is Hive actually does have some persistent tiers in case folks do want to make a ODBC or JDBC connection to what they think of maybe as a database, but we call that Hive Server 2. And as queries are run and executed, they actually run through a bit of a cost-based optimizer to figure out, hey, what's the best approach we can do, and then submit that those activities, that job, into a Hadoop cluster to run something from start to finish. Hive, it's a tool. You got your command line tools. This is an example of Beeline. That's the command line version that's out there. Obviously, you have other visual clients you like to connect to. And then Embari has a Hive view, a good place to run queries, see schema, etc. And the third technology we'll be talking about is Apache Spark. Spark gets a lot of press. It's still very popular, extremely highly innovative, a lot of focus, a lot of interest there. It's a little bit different than these models. That Spark actually is a framework that can run anywhere. It could run on Hadoop, but it could run on other deployment models than just simply Hadoop, or what we call Yarn, kind of the operating system of Hadoop. And what you hear a lot about, a couple things about Spark, you can write your language of choice, so you actually write programs in your language, of the options you have available to you, and you use the APIs that are Spark to help you run your logic at scale. That's really what we're focused on here. And then Spark has, beyond its basic core, has several different additional bolt-ons. Machine learning, definitely the space that really has been and probably still continues to drive most of the innovation in Spark. A SQL framework I'll mention, streaming, graphing, computations element as well. And one thing I would just want to take a minute, and it's hard to compare and contrast, but I did want to make the point here that unlike maybe Pig or Hive, that are classical Hadoop frameworks who go get resources once they know what actions they're going to do, how big the data is, and do some kind of calculations and figure things out. Spark, on the other end of the spectrum, actually goes out and does a bit of a land grab. You have to tell it when you start Spark how much processing capabilities, how much memory, how many, so I need 20 processes, I need them all to be 16 gig of memory, 2 cores, those kinds of things. And Spark creates that before it does anything. So it kind of does that land grab, takes a bite out of the cluster's footprint, but then has some benefits by doing that. And there's that other cluster technology I mentioned, suggested maybe on the last slide, that we could deploy Spark, not just on Hadoop, it can deploy another cluster technology called Mesos as well. I'll focus on using it in Hadoop here. As I mentioned, Spark has some different kind of bolt-on or extensions, or abstractions, or at least extensions to the core framework. The one we're going to focus on is Spark SQL. So Spark itself, at core, the data technology or the data set terminology is what they call an RDD, a resilient distributed data set, and has a very, I wouldn't call it low-level API, but it has a very discrete, very finite, do this activity and do it because I asked you to model, while Spark SQL does a couple things. It lets you bring, first and foremost, familiar SQL to bear, and you can type those SQL statements like you could in your database or like you could in Hive, and then that gets torn down and under the covers via an optimizer to figure out what the best answer is. And then as a counterpoint to that, Spark SQL actually has a programming API, and now focus on that programming API, the DataFrames API, and all the examples in here. Otherwise, our compare and contrast with Hive would look pretty boring, and I actually think the DataFrame API is kind of fun. So we'll focus on that other than maybe one quick example. And then just a quick visual, the Spark SQL, while it's hard to talk about the RDDs, because we didn't talk about the RDDs, the resilient distributed data sets, again, we'll talk about what we call a data frame, something that we are pretty familiar. So data frames make sense when we have a good known structure, columns, data types, those kinds. So some schema that we can apply to data. And then we'll use a tool, or I'll reference a tool called Apache Zeppelin. There are many ways we can run Spark standalone applications, kind of command line shells, these interactive notebooks, of which my company is very adamant and very excited around Apache Zeppelin. But there are other of these notebooks out there. This slide, as it kind of builds out, and I'm not going to walk you through this code, that's actually the RDD. This is a Spark RDD, the more discrete API that sits kind of behind the scenes from Spark SQL. But I just want to take a moment and say my favorite thing always has been that article that came out about a year or three back that said, MapReduce is dead. And I always like to remind folks that's not true. MapReduce is alive and well because all of these frameworks think in that map and reduce paradigm, which is in most cases the foundation for large scale parallel processing. And in fact, in the RDD programming language, if you look really close, programming API, you'll actually notice commands, functions that actually have the word map, and they actually have the word reduce. So you actually are intimately aware of which ones of those phases are occurring. So all these frameworks will be built on MapReduce technology, even though we won't write any MapReduce in here. And unfortunately, with time constraints, we won't try to explain MapReduce. I'll be glad to have that as a one-on-one conversations at some point. So again, what was the title of this topic? It was transformation processing Smackdown. So transformation processing is the T in what a lot of us think of as ETL, extract, transform, and load. And this is just a quick set of bullets of maybe some of the classical ETL requirements. And I will say that what we're going to focus on for the most part in this talk is the things on the left. So things that are easy to understand, visualize, and code. And the things on the right, well, if we had more time, we can go into a little more. But I would say this, these technologies, these tools probably support the vast majority of these requirements, but they support them very generically. They support them as a system a system set of tools. So if you really need to have a really rich administrative tool around, transformation jobs and those kinds of stuff, you'll have to build that yourself, and regardless of which of these technologies. If you do build themselves, again, I would encourage you to piggyback and leverage as much as possible their inherent statistics, job details, etc., that are captured in the system and rolling out at all times. And then I'll just take a quick moment in case it's a new topic to you. There is a theme. ETL is almost always a product that you think about, or a set of product, a company you buy an ETL product and do this kind of extracting from some environment, do some transformation in that processing engine, and then physically load that somewhere else. And the terminology that we often use, or often hear a lot about in Hadoop world, is ELT. So it's really about Hadoop. This concept of like a data lake is really hedged on, at least from the initial part, of landing as much useful or potentially useful raw data sets that you might ever leverage and use. So that extracting from data sources, that loading, really isn't anything more than just movement, grabbing, dropping. We can do things in the middle of movement for sure. We can do stream processing. We can do actionable events. But for this conversation, we'll really talk about using tools like, imagine using tools like Scoop Flume, NiFi, maybe again the streaming engines to help us lift information like Storm and SparkStream, etc. Land that in the file system, and then really decide at runtime or shortly thereafter what kind of transformation activities do we want to do. Are we cleaning things? Are we baking data? Are we changing it, enriching it, aggregating, etc.? And then what do we do with that? Do you live it? It could live right there in Hadoop and use technologies like Hive and others to serve that information up. But it also could be leveraged, or some subset of that be leveraged into other technologies like maybe our traditional warehouse. So ELT as opposed to ETL is a pattern you'll see us talking a lot about. So the rest of the presentation, I know that was a lot of setup. It took us about 15 minutes to get there, so I'll keep pushing on and get to some code examples. The first real thing is, of course, in all this kind of ELT or ETL, we got to get some data sets from other environments, from environments and load them in. So we often think about data sets, files or directories full of files, etc. in the Hadoop world. And I'll just run through maybe those top three there, maybe just some simple, comma, delimited files, separated files, maybe XML, JSON, and allow ourselves to know that the variety of these a little bit more, I wouldn't call them esoteric, but well used in the open source big data environments, maybe not so well used for folks that are new to that. So I'll kind of leave some of that out and actually say as you get into those technologies, Avros, Parquets, Orcs, etc., the world gets pretty easy because these tools are firsthand aware of those, and then of course roll your own solutions, highly mainframe solutions, etc. Actually get more difficult. So let's just take a quick example, a simple little pipe delimited file of books, one book for each one of the technologies we're talking about. So it's title, author, price, and maybe year published, or in this case maybe the most recent version. Some of these books have actually been out there, such as the Pig book for a little while. So we've got a little delimited file, catalog delimiter, and I'll just run you through some, again, code, output, Pig, Hive, Spark, and we'll just kind of follow this pattern for the rest of the conversation. So this is just some simple code. And one thing, as I said earlier in the standard disclaimers, I'm not going to walk us through every one of these lines of code. This is kind of giving you an awareness, throwing things on the screen. And then if you like this slide deck, if you think it could be a useful little bit of a cookbook or something, it's all out on SlideShare. Like you can go to to website lester.website and get to link to my SlideShare, as well as all this code is in that GitHub project that was on that maybe second or third page of the deck. So Pig kind of looks like a programming language. Hey, got me this thing called a catalog, and what am I doing? I'm loading this file, and I'm applying some kind of schema. So there's those 4 fields, and then maybe using terms like describe to suggest to dump on screen what the schema of, say, this book catalog, and then maybe dump to just put it on the screen. So the output of the describe and the output of dump are on this screen. So book catalog, there's those 4 data types, and as you would expect, here's the, once I've loaded up and just simply do a dump, it looks a lot like, visually looks a lot like a comma separated file. That's just how he likes to output things on screen, even no matter where you pull that data set from. In the Hive world, as we think about this stuff, what we're really suggesting is that, to have Hive, quote unquote, write some Hive code for a delimited file, we're just going to create a table. And in fact, this pattern is something we're going to use a little bit. I'll mention again. We're going to use this in many other examples later. We're going to use the fact that Hive could just map a table. In this case, we'll call it book catalog, and maybe pipe for pipe delimited. The normal create table, as you'd expect here, the above the line information, and then maybe what I call the below the line. Where is this file, and what is this file? It's in this location. It's a text file. It's a delimited text file by pipes. Those kinds of things. And then Hive, once you do that data set's easily accessible from a describe, those 4 fields, or just our familiar, select semantics as well to get those 4 fields. Now, as we look into Spark, I did mention, we're not going to focus on the RDD programming for the most part, except that we do every once in a while. I think only 2 times in this presentation, maybe 3 times, 2 times for sure. In this case, we actually, to actually read a delimited file and raise it all the way up to a data frame, we actually have to do a few things. In this case, I'm showing you in Scala, and most of the examples will be in Scala. We'll read a file, that same file we read earlier. we'll go ahead and create a bit of a class here on the fly here that we'll call a book with our type data sets, etc. And then in this RDD programming language that focuses on specifically what to do as opposed to what I would like to get done. I won't walk you through this, but we're splitting, we're tokenizing by that pipe, and then for each one of those array of things that we tokenize via that map function, we'll map it again and construct that book object we created. And then at that point, we actually have what they call an RDD that actually has some schema, something with data types, etc. And then I can just call a simple method to DataFrame, and that was created and elevated. At that point, programmatically, I can just say print schema, as you see there, title, author, price, and year, as expected. And then programmatically, instead of doing a select, I could do .show. Again, what I'm trying to, I'll make a quick point. Once I have a data frame, I can leverage that object in a SQL statement. I could have done a describe on the previous page. I could have done a select all from the name of the variable that I elevated up as a table to my SQL semantics. So you can most definitely in Spark SQL write SQL. Again, my code examples will focus on the data frame API. Moving along, I would just say, just to look at some other quick file formats, an XML file version of that same book catalog there. There we go. Only fit one on the screen. What might that look like in Pig? Well, Pig actually does okay. And again, I got a real flat object here, obviously in XML, but that's probably the complexity I have time to show you here. It gets a little different that I actually have to kind of run through that. I have to, I just simply refer to that XML file as something I just called it raw. And then I have to do this kind of projection concept that takes raw and walks, it's almost like a map, walk every one of those and do something with it. So I'm going to use XPath and to kind of describe what I'm looking for, and then I'll apply it to some schema here on the fly here. And if I have to cast variables of different types, etc. And the Hive version of that, I'm not showing the output because the output's the same as earlier. If I describe, I did a dump, it looks exactly like it did regardless of where it came from a delimited file or an XML file. So I didn't focus on that. And I did take on the Hive version. I mentioned, for the delimited file, I just created a table, pointed that file. I would say that Hive doesn't do all that awesome to XML. So the best thing we can do in Hive, because once we create an external table to an XML file, I really then would have to, in all my SQL statements, kind of use this XPath again, describe what I'm looking for, data types, etc. It gets pretty arduous, and it would definitely not be something your standard business users or your BI tool would know a lot about. So what I'm introducing real quickly is just what we call a CTAS, a create table as, the output of a select statement. So I'll force this select to occur, actually use some real column names, the data types will carry forward. And then I'll have a secondary table. Maybe that's my revisited, cleaned up version of this thing that actually looks like a table that we don't think about and know and love. So again, over in the Spark land, Spark actually does pretty good on things like XML file. And again, we're just chaining these methods together. We have this kind of handle, this object that helps us called the SQL context. I can read something. Well, what am I going to read? I'm going to read a format called, in this case, XML format. Supply some options like, hey, the rows that matter are the books, and then, hey, just what's the file? And then we're off and running. This is much easier reading XML in Spark than it was reading a delimited file. Vice versa, maybe Pig and Hive deal with things like a delimited file like butter, and maybe these JSON and XML take a little more love. I have to do kind of replaying the schema, but definitely Spark, picks really fast up on that materials that are available in those files themselves and often runs. There's no repeat of that information that's in there. And then kind of quickly, just because the JSON version of this is much like what we just saw in XML. So there's the books, 3 books of those 3 different authors, etc. And the good news here, again, Pig actually is just a little bit cleaner than it was with XML. Hey, it's load that JSON file. We have, we use these things that we call the serializer deserializers or surdays. We'll use a JSON surday, a JSON loader, and then I'll just have to kind of declare, piggyback those names that we'd expect to find in the JSON, and then I just have to I'm basically replicating in Pig the schema information that the file itself already knows about. For Hive, Hive actually does pretty good. Much like Pig for JSON, I do have to kind of repeat those fields that I want. He's going to, pick if I only grab a few things out of the JSON. That's okay too. This is a simple example for attributes. So in 4 columns, it all works out nicely, but nothing too crazy there. And then in the Spark code, again, much like the XML version, just painfully simple. Just read a JSON file, tell me where it is. In fact, this one's a little cleaner than the XML as well. So overall, I didn't go into Parquet and Avro and protocol buffers and so on. I focus on file types I think we all have seen, we all know really well. And if I had to rank those just on that kind of technology, on that functionality, I'd weigh them all in and say they're very similar. They have some strengths and weaknesses. Pig and Hive have to kind of regurgitate the schema that's in those files that carry some schema information, such as JSON and XML. But they also do really well at the simpler files, and vice versa. Spark may stumble a little bit and cause you a little bit more effort, but they're all very functional. I think they are all a good simple tie in reading various file formats. Now, I did a real simple book example there just to kind of get us over that reading files. But what we're going to do for the rest of the materials is, actually I'm going to use a simple data set that's out here, kind of an FAA data set focused around airlines companies such as American and Delta over here. They have planes. They're not necessarily a relationship here. Now this is more of a logical ERD. I'm not really building these foreign keys and whatnot, but I think these crow's feet help us all visualize that we may have a big file of flight information that have occurred on a certain day of the year, for a certain carrier, a certain flight number that started and ended at a certain airport, started at airport 1, ended at airport 2, and it was using a particular plane with a tail number of, ABC 123, which is defined there. So these simple 4 data files, that's what they are for us here. They're just big CSV files, actually. So carriers, planes, flights, and airports. Now, what the little line up here says is we're going to rely heavily on this metastore for Pig and for Spark SQL. And what that means is, in Pig, I'm going to go back a few slides and say, if I looked at Pig, when I'm loading things from the initially in Pig, I have the opportunity to kind of supply some schema with me. Now, this is okay for small files, and it's okay for files that we use once or twice, but once Pig needs to read a file over and over and over again, there's a massive lift, and by having these, by declaring a table, by declaring a Hive table that knows about that data. Why? Because at that point, I can then leverage in Pig, I can just simply, hey, read that Hive table, and then pick up and carry forward that schema information. Makes life much better. Doesn't mean it has to go through Hive. It'll use that Hive information to help them find the files, etc., and where they're at, what kind of files they are, etc. And in fact, Spark SQL is the same kind of thing. I can very easily and cleanly say, hey, open up the flight table, which is really the flight file or files or directory full of files, etc., and often run. So we call that the metastore. It was actually on the slides earlier. I'm not going to go backwards, showing the different major components that exist in Hive, but that information is being maintained by Hive, and we're going to leverage that going forward. And I'll try to kind of mention it once or twice as we get off and running. So one of the, back to those requirements, one of the easiest, most thought about understanding requirements is the kind of source to target mappings, data mapping exercises. And this world gets a little more complicated in this, but I'm going to focus on just the simple, I'm mapping A to A, A1 to A2 or A to B. I'm mapping employees, order record, purchase orders from vendors to my purchase orders material. So they're what you'd expect. This is often done in maybe in some of the larger ETL tools that are out there, probably as implemented in maybe a side-by-side visual tool that I'm dragging across and double-clicking, applying rules, changing names, those kinds of things. But they're simple, right? If it's source to target, then there we go. Might have to do something with it, etc. But if it's in the source file, but it's not in my target, great, ignore it. If it's in the target, not in the source, then more than likely I'm making that up, or I'm manufacturing it or morphing it. Maybe I'm calculating it based on some other information. So very simple stuff. And as an implementation, a simple use case that I can show you in code in the time we have allotted, of course, is using that airport information. So this is the one with the airport codes, the name of the airport, the city, the country, geocode information, etc. So I'm going to build a simple target, source to target mapping, and I'm showing in a bullet version instead of a nice table version, mainly because I want to call out a few families, right? So I'm going to very purposely change some names. We call it airport code and airport. I'm going to call that airport, CD. Maybe that's my naming standard, and maybe instead of having a table called airport and a field called airport, I'm going to use the word name. So airport and name. City, state, country. Let's just leave them as they are. Lat long for this particular, just to visualize the what if I wanted to not, I wanted to drop something. We'll just drop lat and long, and then let's just assume we need some kind of governmental agency that's overseeing that airport. So we'll invent that, and we know right now our use case is we're only looking at U.S. airports possibly. So might we put the FAA as the implementation? So what might that look like in Pig? Pig, load, and this is where I'm going to reference a Surday called an HCAT loader. This is the kind of the plug to Oracle. I'm sorry, Org Apache Hadoop, Org Apache Hive, HCatalog Pig, HCAT loader. So this is the guy that's going to say, look, find a table called airport raw, and just bring it in and have the airport names and the codes and those kinds of things. So that's as they were when we initially loaded. So that has schema that I don't have a chance to show you on screen here due to constraints or time, visual constraints or time. But what can I do with it? I can do that for each generate phrase that you probably saw earlier. This is kind of a projection. We project it. And this is my chance to do those kinds of things. I'll rename some stuff, such as airport code to code, airport is name. I'll carry forward city, state, zip. I'm just going to drop lat and long, so they're just not referenced in the target, the thing I'm projecting to. And then I'll just invent government agency as a char array. And just to show you that that worked out, I'll do a describe and a dump. So the describe, there's my new target airport file or data set that I have, and there's those new names. There's that government agency, and then what does the content look like? Again, mainly I dropped the lat and long and added the FAA information as the raw data set that shows up. All right. And Hive, what might that look like? And Hive, I think the best answer here is data mapping. What we're really going to do is we're going to take a table and build another table. We always think about tables. They really are files under the covers. I didn't show you in Pig. There's a command to store that instead of dump it. That would be our opportunity to save it. We'll just use the dump for these examples, but you could replace that with a physical store it off to the file system. What we'll do here is another create table as. So create me a table as, and then in that select statement, do all those source to target mappings, rename some things, drop a few things just by not referencing them, invent, just hard code some things. So now we have another table, in this case called target airport, and if we, dumped, did a describe on it, there's the values that we mentioned there, drop lat long, change some names, got government agency, and then we did our familiar select statement from that. There we go. The airport code name, city, state, country, government agency, etc. Now again, we can, in the world of Spark SQL, we could use SQL, but again, we're going to focus on using the API, and I'll stop repeating that. I just want to say it a few times when you see the code. And this is an example of what, let me go backwards. That select statement here might look like if I use the API. So those that are familiar with maybe object-oriented databases or some of the object relational mapping tools, this might make some sense to you. So, we've got this object that's aware of that Hive metastore, that Hive metadata. I fire our table method off, said grab the contents of the airport raw. That'll create me a data frame, an immutable, at least logically an immutable data frame. All those various columns, I want to get rid of a few, so I'll just drop the lat, I'll drop the long, and I'm kind of building these other data frames. It'll get optimized, and it won't actually make all these passes, etc. But that's how it kind of looks in code. Drop the lat, drop the long. I'll use functions like rename, column or name with column or name to do my simple name changes, and then I'll just add a column. We'll call it government agency. and it'll be the literal of FAA, just kind of a Scala-ism that lit there. But very simple, and from there, I can do the print schema. It looks a little different than a describe in the database land, but same information. And then I could fire off a show with a number, or just show everything, or show me what you can. And this is the equivalent of our select all from. So pretty straightforward stuff. Mapping content in all three of those frameworks. There's really not, if I had to say, is there a real winner here? I think after this one we'll start not having a three-way tie, but I think at this point it's still say three-way tie. All three of these make a lot of sense if you can get over that element of style that comes to bear with them. They're all a little different, but they're all doing the same kind of things. Very straightforward, simple information. Next, we'll spend a little time talking about data quality. This is usually where we do conversions, enrichment, cleansing, deeper validations, those kinds of things. And I don't know if it was clear, but what you probably saw earlier is that we focused on all the data types. Let's see if I can let you see this here. Pop out of that. There we go. All the different data types where sometimes it's easier to describe. How about a carrier, an airport? Well, we use these tables like they ended with raw. Well, those were the ones that they were just externally mapped to some CSV files, and we just left them all as string just to solve problems and didn't have to, what if this broke, etc. That's what we'll do now. We'll spend a little time maybe changing data types, doing some changes to things, maybe some validation, should we have things or not, etc. So ultimately, we want to turn something like that airport raw maybe into, maybe something more like this that had, in this case, a very simple one, just a couple floats instead of strings. But again, let's get back to the slides and see if I can pick that from there. So those kinds of activities, we'll focus primarily on just doing some numeric validation, a little string validation in this example here. So what we'll do is just, what if our scenario was, let's make sure we convert those lats and longs to floats instead of strings, and then let's make sure that they make sense. They're valid lat longs, and there's kind of the boundaries of those two different data sets. Now, in our case, we're going to eliminate them for illustrative purposes. We'll eliminate them from the output. But in all reality, I probably wouldn't throw the records out if I had a bad lat long. I'd kind of notice I would probably null them out and put myself to be revisited file, or even do that with a post when I'm all done. Just do some queries, finding bad things. But our rules here, let's just get rid of those that don't fit in the normal ranges. And in fact, I'll go and tell you now that all my data is well within these norms. So I'm going to change some of these numbers just so I can force a few records to be bad. So what might Delimited Pig? Pig pretty easy. Again, use that hcatalog loader. Use that raw database. So I got a source airport. Do that projection, that for each generate that turns source airport into something like airport converted. Here, all I'm going to do is, in fact, I went ahead and very purposely just dropped everything else. And Pig, I'd have to list those things in the output. Here, I'm just going to focus on the airport code and the lats and longs just to make it a little tighter on the screen here. Simple things, just cast it, And if you can't cast it, that's okay. It's going to work itself out. Those will be nulled out if they can't make the progress from wherever that string value is to lat long. Then I might build me a little data set alias here called maybe lat longs are not null. So I'll just filter that airport converted. I'll look for those that made the cut, that haven't been nulled out, because I want to get the ones, in this case, if they're null, I'm going to move on and leave and not focus on them. And then I'll do a last filter, and again, I kind of put things in italics here because I didn't do a full range check, run out of room on the screen, and those numbers are actually a little wrong here. I just simply said, hey, I'm looking for it's up to 90. I'll cut them off at 70 because I know I'll find a few lats that are bigger than 70 instead of bigger than 90. Same that are maybe past the 170 but didn't quite make it to 180. But you can be a little more elaborate here. So just simple things: filter, cast them, do some filtering to look for the presence of nullable, and then maybe another filter to look for some deeper presence. So these, I'm just building these kind of data sets, and then toward the tail end, as well as any of these intermediate data sets, I could save those off for additional reporting, additional investigation, or I could store, when I'm all done through, more than likely the final data set or data sets back to the file system. For Hive, what we're going to see, to me, Hive's not the best answer for this whole data quality space, because, and this could be that element of style issue that I have. So Hive's an awesome tool. I'm not so sure Hive's, the perfect answer natively, all by itself, and only Hive to do this. And I guess my hang up is that what we end up doing is having a series of tables of information and writing them down. Now we can leverage temp tables and those kinds of things and do, in essence, what we're doing in something like Pig, where we just create a data set, create another data set, create another data set. Except that in this case, if we're not careful, we're actually going to force a persist all along the way. All these little these steps, raw, converted, casted, cleansed, etc. Now the flip of that is, I work for a few clients that's their model. That's exactly what they want. They want all those steps along the way. It helps them a lot of testing, a lot of validation, etc. So for some folks, it actually is spot on exactly what they love. You can still do that with the other tools. You just save them as you go. But there, long story aside, what I'm trying to show here is, this case I really want. Maybe I create a table called a staging table, and it probably is more elaborate than that. But airport stage, that is what? It's just the casted versions, and then maybe I have one more step that's just, and then I want to parse out those folks that maybe don't fit my lat-long ranges. I'll create another one, an airport, maybe it's airport cleansed, or, we'll call it airport final here instead of that. So I'm building these series of create table as the outputs of select statements and moving forward. And then back in, and last time I'll say it, in the Spark, we could write that same set of queries and stuff. We could write those SQL, but we'll focus on the DataFrame API. Here's a situation where we just open that table. And then we do some select expressions. Again, there's a lot of different ways in Spark SQL. No one's expecting that this is new to you to grasp all this. Just what you're really trying to visualize is, okay, lots of method chaining, very functional, program-oriented, series of immutable data sets, at least logically. Maybe they don't all get created, but at least we'll visualize them and then let an optimizer see if it can do some things all at once, and then do less true, real transformations from data set 1 to data set 2. So again, load the table, do some casting from ourselves, filter out things that don't make the lats that aren't good, the lats, the longs aren't good, and I can do some more filtering. Again, I need to be a little bit more elaborate to get the whole range. I just kind of copped out and did a simple little, some simple tests that I know that would isolate some records. And again, if you run the GitHub project and the data set there, etc., you'll see the data sets and the data points that I'm talking about. So we did some numeric validation in that data quality. Let's do some very simple string validation. Let's just trim out spaces left or right, and let's just throw away anything that's longer than 30. Now I think for city, again, we'd probably be a little bit more elaborate, 50 or 100, maybe even 150 or more characters, but I just want to show it a figurative example. Really simple in most of these tools now, right? In Pig, reference the Hive's metadata, just simply grab the airport and just do one of those projections, a for each generate, and we can just do it all on the fly. Carry forward the fields we want, codes and airports and states and countries, and we were focusing very hard on the city, so just kind of embed a trim here that takes care of the left and right. Very similar, what you're already used to doing in Java and other languages. Maybe substring or wrap it around that. We want the first 30 fields, and then whatever that final output is, let's just call that city. We can do some more richer address standardization, etc. But again, we're just doing a very simple rule. Trim around it, and only grab the first 30. So real simple there. That's painfully easy. In fact, the methods look almost identical in Hive. Select the fields you want, and then hone in on that city, trim it, do a substring around it. But the terms are a little less spelled out, and instead of 0 base or 1 base, but same, pretty easy stuff. So create me a table that's really just simple select statement. And then again, I think the Spark code looks a little more interesting when you use the DataFrame API. Grab the table, rename a column, add a column, and this is the kind of weird one. If you do this a couple different ways, I ultimately need a column called city. I had a column called city, so I renamed it city original. That's where I did my trim, my substring, and I called that one city. So then I could drop the city original, the original city field. So that's a quick way to do that in Spark SQL DataFrame API. So the winner on this one, I really think, from my perspective, and I think a lot of people's perspective, and here at DevNexus probably hopefully the case is, as a programmer, probably Pig and probably Spark on the API from DataFrame probably feels a little bit more like the tool of choice when I'm doing a set of this, building this data quality, data enrichment, data cleansing type functionality. I showed you some very simple examples, but it can get a lot more elaborate. And I think for a lot of us, and especially if we're not going to have some visual tool that we're dragging and dropping and clicking and changing arrows and all that good stuff, we're going to write code. Then we want to write some code, and we may not necessarily want to write, just pages and pages of SQL. Again, you can get the job done. Truly, you can get anything we're doing in those other tools we can do in Hive. I just don't think it's the right exact tool for this data quality implementation. Having that kind of that history of all those changes that I couldn't squeeze into a SQL statement as maybe an actual artifact, to me isn't awesome. But again, some people actually think that's leaves them in a good place. So I actually made it third place. I left second place wide open, so tied for first, and I put Hive over in the third. All right, so and then data profiling. So again, as you saw, as I said earlier, like simple examples, a lot of code thrown at you. It's hard to go in great depth in the time we have allotted, but that said, one thing that goes with data quality is data profiling. It's just one of those tools that we use to improve that whole data quality experience and et cetera. And I'm mentioning some basic concepts. We're going to truly, in most cases, data profiling goes beyond these kind of baseline characteristics about the data, the different fields in your data sets, et cetera. But then it gets pretty domain specific, so I'm leaving that. I'm focusing on just the straightforward what can these tools generate data points about the data fields we have ourselves. So in Pig, you actually have to introduce, and this is actually a benefit of Pig. We can bring other libraries to bear, Piggy Bank, DataFoo, so on. So if you bring the DataFoo Apache DataFoo project to bear, it has lots of good statistical tools. It's a very good analysis package, etc., especially for Pig. And with that framework plus just a little bit of coding, very easy and very quickly to get this kind of information here that we just kind of listed on the past page. Normal details about numbers, and again, this can be more than numbers, but focusing on that because that makes a little bit of sense to a lot of us. And so very good, but a little bit of work. In the Hive world, we actually have like your traditional databases where you have statistics. So Hive maintains or can create. I'm sorry, it's optional. Hive can have table level and column level statistics that can be computed. You have to issue and analyze command against your table. If you want to do column stats, you have to say 4 columns, etc. 4 columns, or whatever it is. So you have to issue some commands. Look in the GitHub project if you want to execute this yourself. And then from there, you can ask the magical questions. Tell me about this column. Tell me about that column. And Hive actually does data profiling on all different data types, booleans and strings and numbers and those kinds of things. But again, they're really doing them. These are table statistics, so they're for the benefit as much as anything for Hive later to run and make your help it with it the cost-based optimizer. Help it with things like Bloom filter concepts. Does this file actually even have a potential to have the data you're looking for this query, etc. So lots of cool optimization things, not necessarily from true data profiling. So it's interesting, but again, it's kind of helping a different person. It's not helping you. It's helping you indirectly. It's helping Hive run a little bit better. But it's out there, as long as you issue and run those commands. And again, the more data you have, the more time it takes to crank those. And then, unfortunately, the more the data changes, the more you have to rerun the statistics to have accurate statistics. And then Spark actually has some inherent. You just simply can just do I think the command's describe. interesting enough. You can just simply ask a data frame to give it statistics, but it will only give you based on numbers, and it actually will only give you a handful of these numbers you see here, right? Count, mean, standard deviation, and max, but blanket simple stuff. So if you put all those together, again, and we're not talking about building your own data profiling framework. That's, they're all, go this far. The rest is, what do you want to bring to bear, your special sauce, etc. And I would say they're all pretty decent at this. But Pig, since you have to do a little bit more work to get that, I kind of put him down over in the silver metal space, and I tied Hive and Spark together as much as anything that actually would couple them together. The data that I get from Hive plus the data I get from Spark actually give me a pretty good baseline set of data profile information about not just numbers, but strings and other data types as well. So I tied them first, but again, I see them as complementary instead of A or B. I would say it's A and B. Spark and Hive probably what I would look to leverage in that space. All right, so I'm going to take a look at the time. Running out of time. I'm going to focus pretty quickly here. In that whole transformation, cleansing, enrichment, rigs and gigs, and that kind of stuff, we're going to do a variety of things, and I'll just run through a few of these here, like filtering, sorting, joining, those kinds of things, and just show you some examples of how these tools kind of approach it. So bear with me as we kind of rattle through this rather quickly. Filtering, getting rid of things. You probably saw this in some of the earlier examples anyway, and definitely in the Hive space as SQL, it probably is painfully obvious, introduce a where clause. So we're really doing the same thing with Pig. We're just filtering, by something, getting rid of something. And in the case of Spark DataFrame API, very simple. Got a filter method. Tell me the little filter clause that you need to do, and we'll take care of that. Sorting, very simple. Again, I'm kind of honing in on Hive in the middle. Why? Because I think we all can look at a command, and I just noticed a bug there. I'll have to capture and come back to that on page 69 and fix that. So that val should actually be over here in this line. But a simple select statement. In adding our order bys that you know and love, it's really pretty much the same thing in Pig. Just build me another data set, order the first data set by what I wanted to. So three columns. This first one descending, etc. And then what does that look like in Spark DataFrame API? Pretty straightforward. Get the table, sort it, and that's it. Display it and see it and go on. Joining in Hive, it's actually, in Pig works pretty good, but it actually brings to bear a lot of artifacts that actually usually take some cleansing, so some remap. So I'm joining flights with planes by their tail numbers, and then what's happening, that new thing, that join result that gets created is a pretty verbose everything. I don't have an opportunity in Pig to just select 3 fields from flights and 6 fields from planes, or in this case, everything from flights and 1 thing from planes. I actually get a combined object type or a combined relation there with all of those fields together, with some pretty interesting things like the name of the thing, that the flights colon the flight date. So it's the old original variable here plus its attributes. As well as the other ones, planes plus the things to do. So what I have to do in that world, unfortunately, is more than likely, because I want nice names like flight dates and tail numbers, not flights colon flight date, I have to do one of those projections. And this is something we do a lot in Pig. We project things to the way we want to see them, etc. So in this case, I'd have to actually write about 19 lines to capture. I'm not sure why it says 17 flight attributes. I think it's 7 more flight attributes. So I'll fix that one as well. Write myself a note on the side here. And then if I want to get rid of things, I just don't care. I don't mention them, so I'm going to ignore them. And there's this fancy, changing planes colon year to plane build. So joining pretty easy breezy in Pig. It is a little bit verbose and a little bit cumbersome. Painfully easy in SQL. I mean, you're looking at it on screen here. You know this stuff. Join and tail numbers. Pick the columns you need. Rename it on the fly there and move on. And this is, instead of a SQL version of that, here's the API version of what that looks like. I get the 2 data sets, flights and planes. I went ahead and in fact, from the planes, I actually went ahead and renamed that tail number. I'm sorry, I renamed Select tail number as year. Yes. Oh, I'm sorry. I only wanted tail number and year. Correct. And I renamed year to plain build. So I went ahead and kind of pre-cleaned up the things I don't want, so the join actually was pretty easy. Again, you can do this 2 or 3 different ways, but this is not a bad way by any stretch. And then I just I take the flights, I join it with planes. I apply my, add my kind of condition there. Hey, the tail numbers line up. And then in this case, I go ahead and drop the extra tail number. It's kind of nice that they actually have different names here, tail num and tail number. So I got rid of one of them on the fly for me, and I'm off and running. So real simple ways to join here. Distincts. This is pretty easy stuff. In this case, I'm just looking for the plain database, the plain file. I did the code on GitHub. Kind of does a distinct on types, etc. We find out one of those types is a rotorcraft. And then all I'm doing here from rotorcrafts is what I'm trying to find out is what's the distinct manufacturers of rotorcrafts. So load the planes, filter them out, only carry 4 rotorcrafts. Just from that new data set, get rid of everything but the one column manufacturer, and then do a distinct on the makers, and then I get my distinct rotor makers, which are Bell, the things you'd expect, Sikorsky, etc. Bell for sure in there. And what might that look like in SQL? Wow, there we go. Select from plain, where it's a rotorcraft, and do a distinct manufacturer. We're done. Just painfully take a look at this. Take a look at that. That's not hard in Pig, but boy, it's just painfully easy in Hive. Then there's the select from that in Hive, same data set, answers, and then in the DataFrame API version. Not too much harder, not much more verbose really. Get the table, do a filter. From that, the things that we filter, I just want manufacturer, do a distinct on that, off and done. There we are, Bell, Sikorsky, so on, Special. And then maybe one last quick example here is an aggregation. And what we're trying to do in this one is actually we want to find the top 5 airports that have the highest delay times. There we go. The longest average delay, the highest 5 of those. So we get the flight from HCAT, so we get a hold of this flight's information. I really just want to focus on those 2 fields, origin, departure, delay, the only thing that really matters. So build me a data set, I filter early, and often this is a pattern in all these data sets. You get rid of columns, you get rid of rows quickly and early. It helps with performance. I'll just group that set of just the origin and the delays, group it by the origin so that I can loop through that. So for every departure, the place we left from, the origin airports, I can then say, hey, show me that airport. And then also I'll have for that airport, I'll have all those flights that had the departure delays. I can do a quick average, make a new name here. And then from that, I simply just do an order by descending, highest to lowest, limit that, and then I can dump or save that top 5 delay. There we go, some different airport codes and their average departure delays. What would that look like in Hive? Well, good news. I think you get it. I just want the origin airport, origination airport. I want the average departure delay. I'm going to group it by origin. Order it by the highest to lowest, and do a limit 5, and I'm done. Pretty straightforward stuff. Same data set, same answers as before. And then in Spark, we see that, again, at first glance, it might look pretty intensive, but if you walk it through, and that functional programming is pretty straightforward. You get a table. From the table, I just get those 2 fields. All I care about, group it on the origin, do an average, create some names, just like you would in SQL. And there's my way to kind of do the as, so rename this thing that got created to something like average departure delay, sort it, descending, and then show me 5 of those, and I'm done all through. There we go, same answers that you saw before. You put all that together, these kind of core processing functionalities, based on what I said earlier, that this is kind of conflicting messages here. I would say that again, I think many of this functionality we're talking about here belongs in that framework, that overall cleansing framework, that big transformation job we're doing that I already suggested. I didn't think Hive was the best answer for that. But I would say, especially on these limited, just one off at a time, just do this, just do this. I went ahead and kind of edged out and said, you know what, truthfully, expressing those concepts in SQL, we all know how to do it. It's pretty darn straightforward. And if you really say that Apache Spark SQL could actually support SQL as well, you actually have a power to mix and match these things. You can say, hey, great, the things that make much more sense doing a little bit more programmatically, great. And then sometimes it just makes sense to run a SQL statement. Do that. You can mix and match that in Spark SQL. So you could argue that Spark doesn't have to be as closely following second place and could really be kind of and or here. But again, I put that as closely following. These are very straightforward. I think that, at the end of the day, it's elements of style that sometimes are going to be jumping from one group to another. I'll try to wrap up. I know we're running way out of time. So as I'm doing my timing, I'm about an hour in. I got an hour to do the topic. So this one's around custom business logic. So we use a phrase called UDFs, user-defined functions. Pretty straightforward, been around forever in Pig and Hive. You just write just some Java code to the appropriate pattern, compile it to a jar, get that jar somewhere available, register the jar in your code so you can use it, and then reference that function, go crazy and use it. Hive has a nice feature that can surface those across a database, so I don't have to do that in all my scripts in different places, and it's available especially for those JDBC and ODBC clients, so they just can leverage that. And then Spark actually does, I think, one more nice thing. It actually makes it painfully easy right there, right before you need it, just to, hey, I got this function. Wrap it with a UDF and you're off and running. So a good example here to kind of come back and when you get a little time and take a look at just converting, simple things, flushing the years out. Obviously, there are date functions that help you do this kind of stuff, but just want to show you. In fact, the rest of the code note in the deck was Scala. This is a little bit of Python just to shake it up and have a little fun. So business logic is pretty easy breezy. They're all good winners here. If I had to rate them kind of 1, 2, 3, I really just said, because Hive can let us easily, get it out there for all Hive users for a particular database, we can easily make an existing UDF available that just edges out on Pig. Very easy. They're very similar how to build a Pig or a Hive UDF, but that availability feature was nice. And then again, I really value the fact that the Spark SQL, I can just put it right there in the code base that I'm creating. I don't have to do something externalized, and I think actually that edges it out. A much bigger topic that we definitely don't have time to go into here is that notion of all these systems are built around immutable data sets, and the reality is data is changing, and it's a pretty common pattern practice out there to kind of adapt to that and go forward. I just invite you, if you had time, to take a look at there are many, I wouldn't say many, there are several kind of themes out there that people support. I don't think what I'm advocating in this SlideShare, this YouTube video that I presented at a previous Hadoop Summit conference, I think it's actually a pretty good approach. There are some different perspectives out there, but you can get some really good feel of what's going on in this space. But it involves, guess what? Bringing data, melding it together with what you already have, build some replacement data sets, and then, in fact, replace, delete and replace things that you rebuilt together, and possibly do some other things like compaction. So a big conversation here, a whole topic, a whole presentation all by itself. Spend some time if this is your world as well. If it's time series immutable data, no big deal. We're always editing and working on that. I think that all these frameworks, they all handle it pretty equally well. I nudged out Hive as the big winner here because Hive does have some early attempts at bringing much more kind of row-level semantics, inserts and updates and deletes that we think about in traditional database systems. I want to be cautionary and say that that does not make Hive a RDB, relational database management system replacement. That's not what it's trying to do, and there are some technical constraints that have to happen, certain data set types, data file types, etc., file types, and a few other things that have to occur for Hive to do that. And then they just have to fit in the right characteristics, which really mean we're not turning over 50% of the data every 5 hours or something. It's usually generally speaking, a small set of data we're doing across the overall, and that turn radius shows. It doesn't mean tiny, but it definitely means a much smaller percentage of the whole than a lot of the whole. So a lot of really interesting things in that space. I'd edge Hive out in that manner. Last section or two, I think performance and just a little bit more here. The truth is, we're running out of time, but the good news is these frameworks I mentioned, MapReduce really isn't dead. It's still the concepts of map and reduce are leveraged like crazy. The framework, the Java MapReduce framework, has been improved upon. We have a framework called Tez. Spark itself does MapReduce. And some of the things they realize they can get away with is just not having to do intermediary results back to things like the Hadoop file system. It takes a little time to do all that kind of stuff. And then just realizing sometimes I can do, I have a need just to do reduction without having to go through, a mapper layer, and that was a gotcha that MapReduce forces us to go down that path. So the little things like that make lots of optimizations that are curves. This visual graphs, these little DAGs over here are trying to explain that again. Much worthy of a deeper conversation for sure. Just want to put a little bit of graphic to kind of piggyback these two bullets. Definitely Hive and Spark SQL themselves, have query optimizers. They're trying to think and act like databases and do smart things. But the real winner here is going to have to be Spark, and it's going to have to be at a consequence, because Spark, as I mentioned, I'm going to introduce it lightly earlier, Spark actually goes out and does a land grab. It grabs all the processing capabilities it needs. If it can't get them, it won't even start. But once it gets them, even if it doesn't need them, it's going to hang on to that kind of footprint. And because Spark can run on different clusters, Spark actually does its own scheduling of tasks, its own little task manager of sorts that's measured in, again, millisecond type, that time to do this, time to work on that, etc. That's usually measured in much more seconds from overall. We don't have to go back to the yarn environment. Hey, I need another process, etc. So Spark will, overall, I think it's fair to say that Spark is going to win the overall performance numbers. It really is going to depend on the use case, highly iterative functionality, processing on the same data sets. Spark can get, not just 2 times or 5 times or 10 times, but, can get much higher X's on improvement, but just straightforward read a file, turn it to this, turn it to that, straightforward ETL, no repeat of information, etc. We're not going to get a 10x improvement, but you are going to get a lift that's often measurable, noticeable, and acknowledgeable real quick. And the only reason I edged Hive on top of Pig maybe here is because Hive has done a lot of work with data set types like ORC, and a lot of work with frameworks, execution engines like Tez, a lot of work with the optimizer that, in many cases will edge out and be much, maybe not just edge out, but beat out the Pig scripting language here, even if it's leveraging some of those same kinds of things. So there's a lot of functionality, a lot of features that kind of put in that Hive space as well. I will say that Hive is introducing its own caching framework called Live Long and Prosper and other things. So some of this performance you're going to see edge out as Hive actually starts to do some of the things that Spark is doing as well. And that's material that's out already out there in those Apache projects in the hive.apache.org. But I thought it was fair just to call out Spark as the big winner there. All right, so get to the end of the deck. Really just, I know I threw at you a bunch of short snippets of code. If these frameworks are new to you, great. What you probably want to do is pull this deck down again and or pull up that GitHub project, get you an environment up and running. All the vendors have their own little sandbox of sort to make it very quick and easy to get a Hadoop cluster running. But I think it comes down to kind of those bullets you see there that, definitely it's around the investments. What have you already done? What are you already doing? And definitely, where do you believe these frameworks are taking you? The reality is you have choices, and they don't necessarily have to be A or B. They could be A and B, or A in these scenarios and B in that scenarios. But just as important about what you've already done, it's really about, as you grow this and scale this, what can your team do? What do they understand? If your team really understands SQL and they're not programmers, you're probably going to look to Hive, and you may lean into Pig, but you probably won't jump into Spark because it's a little bit of a jump in some cases for the folks you're building code and a familiar IDE, etc. So that whole existing investments, what do you know how to do already? What can you learn how to do quickly? And then just, as a counterpart to the, where do you believe these technologies will be? Which one fits you? Which one fits you well? I have to admit, I'm a bit of a Pig advocate because, before I got into Spark, it's Hive and Pig, and I really like to write a little bit of code. It's what we do for a living. And I had a little more fun writing Pig scripts than running Hive scripts, so maybe that influenced and biased me a little bit there. So matter of style does come to bear to you. And then I'll end it with that phrase there, polyglot programming. That's not a bad thing. Realizing that you might need different technologies, languages, frameworks, etc., that come together and to comprehensively build a solution set and solve a business problem. That's not necessarily a bad thing. It may feel bad, but it's not necessarily a bad thing. And you're going to see that polyglot persistence and other things out there in the big data space that you're going to find which things solve the best for whatever. And again, you just have to learn to accept it and grasp that. Best thing you can do is keep researching, go to local groups, go to these conferences, read blogs. But if you can give back, that'd be even better. So learn a little something, write a short little blog posting about, hey, I did this. You would be amazed how many people find and read these things and send you emails or comment and say, thanks so much for doing that for you. Just the little things you can do go a long way. So I'll end it with my question, slide, name, etc. on the board there. In case anyone wants to reach out to me, find this deck, the corresponding GitHub project, etc. Hopefully this will go just slightly better. When I delivered at DevNexus, I'm about an hour and 11 minutes, and I was shooting for 1 hour, so I have to speed my delivery up, or trim a few things out. So love some feedback if it was way too fast for anyone, and I actually think if anything, I probably do need to slow it down a little bit. Thanks for your time.